Alright, these problems want us to write a particular equation for the sinusoidal graph. So there's your basic formula. Different books write it different ways, but that's the way many times you'll see the formula written. So what we need to find are A, B, C, and D over here. A is the amplitude. So for this one, the amplitude, notice that this is the center line, that dotted line. So the amplitude is going to be whatever this total distance is from 25 to 45, which is 70, divided by 2. That's going to be your amplitude. So A equals 35, and it could either be a positive or a negative 35, depending on where we start. And so let's say that we're going to start right here, and so we'll keep it as a positive because it starts going up. The next thing we need to do is find B, and remember B equals 1/2. Let me write this down here a little bit more. So A equals 35, B equals 2 pi over the period. So the total period, notice that it starts at -7 and it goes one full cycle, ends at 33. So the period is 40. So B equals, I'm sorry, this is in degrees, so it's not 2 pi over 40, it's 360 over 40 since this one is in degrees. This one down here is in radians. You can assume, actually no, you probably should assume that that one's in degrees as well, so never mind that. But sometimes you'll see these in radians, in which case you use 2 pi over B, but in this case it's not that. So since it's in degrees, the 10s cancel out and take half the 36 twice, or divided by 4, and you get 8. Sorry, you don't get 8, you get 9. So B equals 9. C is the horizontal shift, and you'll notice that it doesn't start right here, it starts 7 back, so C equals -7, and remember when I put that in, it's going to turn into a +7 on the inside there. And then D is the vertical shift. So my vertical shift here, notice that it's starting lower, and so the period is 35, so that means that the distance from, I'm sorry, not the period, the amplitude is 35, so the distance from here to here is 35, which means that's -10 right there. So D equals -10. So your equation is going to be y equals 35 sine of 9 times x plus 7 minus 10. That's the equation of that first graph right there. Second graph, you can do it the same way. Let's try this one. So the amplitude, notice that the total distance between 15 and 19 is 4. So the amplitude is half of that. So A equals 2. B, again, we're going to look for the period. So look at where it starts. There's the starting point, and there's the ending point. So it starts at -40, and it ends at, hard to tell exactly where that ends. Let's see if we can find a better starting point and ending point. No, not really. Kind of hard to see, because that looks like it's at 5, not at 10. This doesn't quite look like it's at 60 if you were to draw that up. So I'm going to guess that that's maybe 55. That's just a guess. So 55 plus 40 is 95. The graph isn't drawn very well, so it's a little bit ambiguous. So let's guess that the period is 95, and so we're dividing 360 by 95. Actually, on second thought, this looks more like 90. So this probably is 50. The reason I say that is because there's -40 right there, which looks pretty clear, and this looks about halfway in between, so that's probably 5, which means this distance, half of the period, is 45. So a full period would be 90. Plus, that's a little bit easier to deal with, because then we just have to cancel out the factors of 10, and then this becomes just 4. So B equals 4. C, which is the horizontal shift, is -40, and D, which is the vertical shift, it goes all the way up right between 15 and 19. Remember, that's 2 away, so it's 17. So the D is 17. So your equation would be y equals 2 sine of 4 times x plus 40. Remember, you're shifting left, so it's a positive, plus 17. There's your answer.